and a most certainly existing reality where this happened. Yeah, and from there, now that you can track all of these specific predictions for how players move through your game, how does that help us here? Like, yeah, we can get, okay, they go down certain paths, but going down certain paths does not necessarily translate into going down more paths. It does not necessarily translate into spending more on certain paths. Like, you have to translate the paths taken by players into something which is compatible with this. And that is where you solve for KPIs, key performance indicators. Now, key performance indicators are super useful. There's no finite list. Like, if you are having trouble in any of these areas, by all means track for it and track your improvement over time. Because, like, if we learn that, say, they have a horrible onboarding experience, we'll want to track for that as a general key performance indicator as well, because it influences all the ones that matter. But in general, track these ones. Figure out your retention rates, figure out how long they're playing, and figure out how much they're spending. This would be in the form of average revenue per user. And yeah, so that's these are the important parts. We solve for these, and we figure out how certain paths influence these various metrics. We can have positive. One way to do this is through positive correlations. This is the way we measure. This is where we take a complicated system like survival rate, like we take the measurement from survival rate that doesn't directly translate into retention rate, and then we figure out how often it kind of does. A positive correlation goes from 0 point infinitely small to 1. Negative correlation goes to from 0 to -1, and no correlation. Well, that's just a 0. Yeah, and the same thing is positive. When something's positively correlated, change in A equals a change in B. Negative, change in A equals opposite change in B. And no correlation means changing A does not affect B at all. Yeah, you'll notice the green and red lines are also correlations. This is pretty basic stuff, but important. Secondly, now that you have a way to actually determine whether or not a certain behavior is influencing things, you need to filter. Because here's the thing. Did you know that? Let's see. What's a good example? It's like. Did you know that the average motor vehicle in the United States has less than 4 wheels, but more than 2? Like, technically, because motorcycles exist, the average number of wheels on a motor vehicle goes down below 4, even though 4 is the most common type of vehicle. But because you've gotten the average, or even like you can't really tell what that vehicle would look like. Like, what vehicle has 3.8 wheels? That doesn't make sense. You can't work with that because that isn't real. You have built something from the numbers that does not exist. And because of that, we need filtering. And by the way, the answer is not just use a median, because if you got the median number of wheels, you just get 4 and annihilate the existence of motorcycles, which, as you can tell from how loud they are when they drive past here, they very much exist. And yeah, so from here, we have the overall retention. Like we have different ways to split stuff. This is actually an old query I made in this language called KQL in PlayFab. We're not going to be using PlayFab too much because I think Power BI does everything it does better, except for data storage. And but yeah, this is an example where if you look at, say, the touch versus keyboard. If you were to average out the touch and keyboard audiences, you would get a certain session length of 249 seconds. But then, when in reality, keyboard users are playing for almost an entire 2 minutes longer, whereas touch users play about 30 seconds shorter. So really, there are 2 categories here. A keyboard group, which is having a pretty great time in terms of playing through in a single play session, but then touch users who are having a bad time. And if I hadn't filtered through these audiences, I wouldn't have known that. I wouldn't be able to figure out that this state, because state at the end of the day, state only makes sense on an individual level. Whenever we combine states together, average them out, We are making something that isn't real but could be close to reality. That's a key thing to remember. You have to watch out for those hidden influencers. But yeah, so for now, just know filtering and splitting up the data set into smaller and smaller groups that can be helpful. However, it comes with a big asterisk, and it's probably one of the worst things about analytics. The reason that analytics is not something everyone does, the biggest reason I've seen cited against it, is it's expensive. In order to really get the most out of analytics, you need a lot of users. If you don't have a way to advertise your game, if you don't have a way to get people in there, you cannot get enough users to have a reliably low error margin. Like, look at this. Here is the 100 trials in rolling a die, and you can see the average, the theoretical average for rolling a die will get you a 3.5. Once again, average does not provide you with reality, but in the reality itself, there's errors. There's skewing from the predicted, and because of that, you have a kind of an issue. If you only roll it once, there's only for one, there's a zero chance that you'll get, with just once, there's a zero chance you'll get 3.5, but even twice, you could skew all the way up to like 5 point, like what would it be, if you got a 6 in one, and then I guess a 4 or a 5 in the other, you get a 5.5. It actually shows it there. That's a 5.5. That's the biggest skew you can get, which is almost like an 80% margin of error. That's horrible, and that's what happens when you use a single testing data. Like, by all means, it's 100% accurate to what happened that specific time, but you cannot apply what happened there across everyone. And so, yeah, you need at least a few hundred in the sample size area. Like, from there, you can see it a little bit illustrated here. You can, like, you may think, oh, it's okay. I'll just have 1,000 players. That's only 10. That's only about a 5 to 10K in advertising. Like that I can afford that. That's yeah. Like what? $15 worth of Robux can get you into here. That's enough for success. And the issue from that though is the filtering from before. Notice this. Look at this. Retain true, 8,800 out of the 8,900. Retain false, just over 100. That is a massive disparity. Like, and even worse, like, I'm trying to remember what game this was to have such a massive difference in retention length. Okay, maybe I just swapped the labels or something. This is a pretty old photo. Anyway, I'm not teaching you guys how to use this tool because it's messy. But like if you look, keyboard versus touch is another example where only about a fifth of the audience is using keyboards, yet it seems to be the better audience. And that, you can see it here. Here's a random pie chart I got from a website linked here. But right here, with the population of 3,000, which is where you can get from a good $20, $30 in advertisement spending. Like, not like if you don't currently have much money, but you have the time to make a game, you have the time to earn $20 to $30. Like, that's the thing. People always tell me, it's too expensive. I can't do this. Like, either it might be too expensive for you. But that too expensive for you part comes from you having the time to make a game. If you have the time to make a game, you have the time to earn enough to advertise it. I do not accept that as an excuse. If you have the internet, I've harped on that long enough. Okay, point is, you have this group of 3,000 people. This is assuming an even distribution, which, as we just saw here, with retention being a huge, like PC versus touch, skewing wildly in the favor of touch, which is true in real life, typically. This is just more for simplification. Because even with a simplified system, it still gets really bad really quickly. So we split it once into 3 groups. Okay, like if we do a filter to see just how domain expertise people use it. Okay, that does this. Okay, what about people with just programming skills? Okay, they perform this way. What about people with just math skills? Oh, they perform this way. Okay, now from there, overlap again. Uh, 350. That's 350. Now remember that this part, 350 users. That's not the best margin of error. Like it's workable. Like it's about 7%. Um, but we'll see in a bit that the error margin really can matter at times. So we'll like, and then from there, what do you think of this data scientist? What do you think is going to happen there? 100. That's 100 users, a 15% error margin. Yeah, and so now let's swap these out with real life game terms. We're like someone returning, a person who uses mobile, and a person who completed an event in your game. These are three different groups, and there are only like you can imagine how a returning user who completed a certain event how that could dramatically skew which paths they take because there are so many variables there, so many things about their situation which could influence it. But like for a population of 3,000, that audience with a very important demographic that makes up a lot of people can only really be represented with something that's like 3% the audience size. Am I doing that right? Yeah, it's 3%. Oh. Yeah, and with that 15, like maybe you can think, oh well, 15% error margin, that's not bad. We can work with that. I've had 15% error margins on exams. Like it's fine. Yeah, and for that we're gonna have to. Well, I guess before we get to move on to the next part, let's just focus on the reality of this. If if you have, say, a retention rate of, let's just say 10%, and that retention rate needs to get to 12% to get those discovery players that I was telling you about, or even just that you change something. Like let's say you make an update and your 10% and your 10% retention rate increases to 11.5%. Tell me, did that happen because you tested and improved the game, and the thing you did made the game better? You literally cannot tell me with this error margin. You cannot tell you. It could very just as easily be this error margin. Like you could have just gotten unlucky, rolling a bad die, and had that result show up as fake. Like basically mislead you, trick you into treating your game differently. And who knows? Maybe you might. What's even worse is you might even have sacrificed other metrics to get that gain, but because of the error margin, that gain isn't real, or it might not be. So, with the higher your margin of error is, the more dramatic the change needs to be. And with stuff, especially with like retention and session duration, where a change could have a very minor effect, like you need to be able to track this stuff, and the more, and like analytics is hard enough when you have a lot of data. When you have not much data, it's way harder. And so yeah, the more people you can run through your model, the better. And that's what makes analytics expensive. That's the big barrier, because every time you want to run a test or like run people through the game, you need at least $30 usually. Like if your game isn't already successful, you need to pay for those new players. Like if you aren't getting free discovery players, that'll cost you. And yeah, it's rough. I don't recommend trying to make all of this work with just 100 players or 50 players, because the error margin would be ridiculous. You would most likely mislead yourself rather than learn anything. Do not mess with small numbers in these. I don't know. This is me begging you. But yeah. So now we're going to get to visualization. And because